Assalamualaikum. So today we will continue on another example. So let's look at this example. Okay, so yesterday the example that we have go through was xn, okay, equivalent to an. So what if you have it in terms of a minus an? So let's see what are the solution. Okay, so solution is, okay, so find x z. So xz, so write out the general equation. So xz is equivalent to, okay, summation of from minus infinity to infinity. This is the general equation, xn dot z minus n. So what you need to see, look at is that this xn value. So the xn value is this one. Okay, so xn, and you see that in the xn value you have un kan, un. So what was un? Un is actually a step input. Okay, step input meaning that it starts from 0, 1, 2, 3 until infinity. Okay, so the signal is until infinity with a amplitude 1. Okay, so until infinity. So how about the negative side? Negative side, all is 0. Okay, so this is called a step input. So when you look at this question, okay, you know that the summation here is going to be from 0 until infinity. So you're going to write again the equation with this value lah. Okay, so let's just write out. Okay, let's say that we write out again minus infinity to infinity with the value of xn inside. So a minus n, okay, un dot z minus n. So un, you define it as from 0 until infinity. Okay, so this is un. So what is the un value? Amplitude is 1. And you have here, it's starting from 0 until infinity. This is correct. So you can rewrite again the equation is 0 until infinity a minus n. This one you already substituted to 1 dot z minus n. Okay, so you have the equation like this. So just expand it, okay, or factor it. Okay, so then you have a z minus n. So using the mathematical theorem, you know that you have n equal to 0 until infinity. A squared n is equal to 1 over 1 minus a. Okay, so it doesn't matter if the n value, what are the n value, then you can write it out again as 1 over 1. So what's your a here? A is, this is a, 1 minus a z. Okay, whereby you have minus 1. Okay, so you can rewrite it as 1 over 1 minus 1 over az. So this is the answer. Okay, so how can we find the ROC? Okay, so ROC is you take out this equation. Okay, so you have 1 minus 1 over az is smaller than 0. So rearrange that, you have 1 minus 1 over az minus 1. Then you have 1 over az less than 1. So az bring it up, and you have equal to 1, and z is more than 1 over a. Okay, so you have the ROC is given by this value. So example, if you draw out the ROC, so you have here 1 for the ROC. This is z plane. So let's say that 1 over a is here, 1 over a. So 1 over a is this radius, and z is more than a, then you have here covering the unit circle. Okay, so means that this is stable. Alright. Okay, let's look at another example, example 3 here. So you are given an equation xn equivalent to minus en to the power of n, u in bracket minus n minus 1. Okay, so let's look at how can we actually draw out the equation for un over here. And then by using z transform equation, then we will determine what is the z transform, okay, for xn. Okay, so let's do this example. So the solution for this, okay, make sure that you are following me and writing it out. Okay, so let's look at what are the equation that we have. So from this xn equation, you can see that you have a step input signal, but the step input signal is in terms of you have the time transformation. Okay, so what are the time transformation that you have? You have u minus n minus 1. Okay, so what are the time transformation? You have a time shifting, which is time shifting to the right side, and then you also have here, right? So that is a time reversal. Okay, so let's just draw out what is the signal for un. Okay, un is you have 0, 1, 2, okay, with amplitude 1. Okay, so this is until infinity. Okay, and then we will start to do the method. This is method number 1 that you have learned in chapter 1. So method number 1 is that you are going to do the time shifting n minus 1 first. So we do that. So you know that when we have the time shifting by minus 1, is that you're going to shift it by 1 to the right side. So you draw it as this is 0 is being shifted to the right side, dot dot dot, until infinity. Okay, so this is until infinity with amplitude 1. Okay, so you have completed this time shifting. Next is time reversal, since you have the time reversal over here. Okay, so time reversal is that you take this signal. Okay, the first method was time shifting. From this, you do a time shifting, okay, which is time shifting. Then you do a time reversal. So time reversal, you have from this signal un minus 1. Okay, so time reversal is what? Time reversal is actually you reverse the signal. Whatever you have over here, you multiply it by negative for the time value. So you have 0, minus 1, minus 2, minus 3. Whereby, if you plot again the signal, then you have minus 1, minus 2, minus 3. At 0, you have 0. At minus 1, you have 1 here. Okay. Then at minus 2 is 1 until minus infinity. Okay. So this is how you do the time transformation. So you can see that what are the value that you have. Okay, so if you would, because next is that you need to answer this question. Find what is xz. Right? So if you want to find what is exact, then you need to know what is the general equation. So for A, okay, xz general equation is given by the summation of n minus infinity into infinity xn is z minus n. So you see that you need to determine this value. What are the range of summation that you have? So for your case here is that you need to refer to this last signal lah, that you plot. So what are the value? It's from minus infinity until minus 1 lah, over here. At 0, you don't have a value. Okay, so it's from minus 1 until minus infinity. Okay, so let's substitute value. So let's just substitute first what is n, the xn value. Okay, this one. Substitute into this equation. You get minus en, okay, u minus n minus 1, okay, z minus n. Okay, and right now, you know what is this. Sorry, not until here. What is this? Okay, this one is the signal that you draw just now, and it's the summation is from minus infinity until minus 1. Okay, so meaning that, and with what are the amplitude? Amplitude is 1. So you can write that one, this one is amplitude 1 for the summation from minus 1 until minus infinity. So we rewrite again this equation as from n equal to minus 1 until minus infinity. Sorry, it's from minus infinity. Okay, so it's the wrong way. Okay, so you have here okay, n minus infinity is correct, but is it for until infinity? No, it's until minus 1. So this is until minus 1. So this is until minus 1. You have value an. This value is equal to 1. So z minus n. Right? So if you rewrite again this equation, okay, you will have minus infinity until minus 1 minus a z minus 1 to the power of n. Okay, so and if you look at the equation that we did in the previous example, we want to solve this whereby we want it to start from 0 until infinity. Okay, so we want it in a positive side. So meaning that in order to solve this, okay, we want to reverse, okay, reverse the limit, okay, from n in become minus n. So therefore, we can rewrite this as, okay, since we want to reverse that, then this one will actually be in the reverse. So from, and we multiply it by minus n, so you will get 1 until infinity. Okay, minus az minus 1 to power of minus n. So this n value you multiply with minus 1, and this one you multiply by minus 1. So this one minus jadi positive and positive. Okay, so after that, we can proceed to the equation. Okay, we take out this negative value, take it to the front. So you have minus from 1 to infinity, okay, az minus 1 to the power of minus n, whereby you can rewrite this equation as minus infinity 1 to infinity, okay, a minus 1 z n lah. Okay, so you write it again, just multiply, you write it in this term. The tricky part is that, okay, for the mathematic theorem that you have learned, okay, you want to, in order for you to convert from 0 until infinity, okay, this is the maths theorem. You want to convert a to the power of n is from 1 over minus a. Okay, so you want to have it in from 0 until infinity. But your equation is that you have it from 1. So we need to rewrite this back again. So let's assume that okay, we take out this one minus, okay, summation of 0 until infinity a minus 1 z to the power of n. Okay, so and then you will see that, okay, for this just now, okay, this equation just now, okay, if I rewrite again, I draw it again, okay, so you have it from minus 1, minus 2, minus 3 until infinity, okay, sorry, not based on that one, we are going to do it based on this one, so we refer to this, okay, if you look at the signal, it's a summation from 1 to infinity, so 1 to infinity meaning what? So you have 0, 1, 2, 3, 4, because we already reversed that, so we will start from 1 until infinity. So 1 means that start from here, and then the other part is 0. Okay, so but we need to rearrange so that your signal will start from 0 here. Okay, so you want it to start from 0. 0, 1, 2, 3. Okay, so if you do a summation over here, so what are the missing signal that you have? You have the missing signal is at this one, okay, so this is at what value? N equal to 0, right? Okay, n equal to 0. So meaning that, okay, you can rewrite this equation. This equation is, okay, this equation is you can rewrite this equation as, okay, equation 1 minus equation 2. What is equation 2? Equation 2 is at 0 you have only a signal, okay, which is at n equal to 0. So if you subtract that value, okay, you will get this signal, correct? Okay, so 1 minus 1, you get this signal back. So therefore, when you write this, you can rewrite it as a minus 1 z. What is n value? N is equal to 0. Okay, so n equal to 0, this one is 1 lah. Okay, so you have, in the end, you have summation of 0 to infinity, a minus 1 z n minus 1. So now only you can use the equation over here, this one, okay, to use it in this part. Okay, so you have minus, what do you have? What is the a value? A value is this point. So you will have 1 over 1 minus a inverse 1z minus 1. So you can rearrange this again. So 1 minus 1 over 1 minus a minus 1z. Then cross multiply this. Okay. So you get 1 minus a minus 1z minus 1 over 1 minus a minus 1z. So this one is cancel out. Then you get minus a minus 1z over 1 minus a minus 1z. And because this is negative part, so you rearrange that as a minus 1z over a minus 1z minus 1. Okay, so this is the equation for exact. So what are the ROC? Okay, ROC. So ROC is that we refer to this one, right? So ROC, okay, you take that out. So you have a minus 1z minus 1 smaller than 0. Then you have a minus 1z 1. Okay, this is z over a, z less than 1. A, yeah, less than a. Okay, so if you refer to the table, okay, table of Fourier transform, you can see that what we did was this signal number 3. You have minus u n minus 1, whereby you have just now the alpha value lah, the a value. So you can see that when we derive it, the ROC is z less than 1 or z less than a value. Okay, so this one is either you can refer to 3 or 6. It's the same thing. Minus alpha n, u minus n minus 1. So you have z less than a value. So this is what you just derived just now. So if we were to draw the ROC, so the ROC is 1. Example that ROC, okay, A here, for example, A is equal to 3. Okay, so A is 3 is here. Okay, so if A is 3, then you see that it's actually covering the unique step input lah. The unique step input is stiff one at the radius 1. Okay, so this is Z plane. So we will say that this is stable. Let's say if what happen if you have A equal to 1 over 2. Okay, if A equal to 1 over 2, okay, so let's draw that out. You have this is unit step 1. If A is 1 over 2, where is it? It's here, 1 over 2. And you have the ROC is Z less than 3. So less than 3. So you see that this is unstable. System unstable because of the ROC doesn't cover the unit step. Right? Let's look at this as a recap. Okay, so you have what you have here is that, okay, you have learned about when you have a signal xn, and then with this type of signal un, so you know that when you plot the signal un is going to be the right-sided sequence, right-sided sequence, RSS, right-sided sequence. And from the right-sided sequence, you found out that okay, you can actually derive that the ROC will be more than the value, more than A, example. Okay, so it's going to be outward ROC. Okay, and then a second one is that you have to look at the left-sided sequence. So left-sided sequence is that when you look at the value of UN here, and then UN when you try to plot it using the time transformation, then you know that it's going to be on the left-sided sequence. And all for the left-sided sequence, you have also proved that the ROC will be less than A. Okay, means that less than A. So for example, if you have A here, so less than A. If this is A, then more than A. Okay, and when you have both the left-sided sequence and right-sided sequence, so you have the right-sided sequence over here, and then you have the left-sided sequence. Okay, so when you have both like this, then you know that you have both right and left-sided. And when you have both right and left-sided, then you will have the ROC is like a donut shape lah. Okay, donut shape whereby you have Z. Okay, for this case Z is less than R2, and also Z is more than R1. Okay, so let's look at an example 4. So let's consider a signal that is a summation of two real exponential. So if you see this example is that the xn value is given by, okay, one signal, okay, 7 multiplied by 1 over 3 to the power of n un minus, okay, 6 multiplied by 1 over 2 to the power of n un. So if you and the question is that determine the Z transform. So what is xz? Okay, and then from there sketch the region of conversion for the signal xn. So get what is the ROC. So let's look at this example, how you're going to answer this example. So for this example, okay, we are going to do it using by inspection, or by directly looking at the Z transform table. Okay, so from the Z transform table, we can actually write again the equation. Okay, example, we have xn. The question is xn 7 1 over 3 and un minus 6 1 over 2 and un. Okay, so this is 1 over 3. So from here is that, okay, by inspection using the Z transform table over here. Okay, so if you, let's say that we rewrite this equation as, okay, 7 a and un minus 6 b, so we write as 1 over 2 is b and un. So you can see that this equation is actually the right hand side sequence. So a to the power of n un also for this case is the right sided sequence. So when you have the right sided sequence, then we directly know that the ROC is Z is more than A. Okay, so let's continue here. Okay, so by inspection of the Z transform table, Okay, we are going to split this into two. So you have here, let's say we write it as 7 x1 n minus 6 x2n. Okay, so by inspection, okay, x z, so you have 7 here, x1n, let's say we are going to do only for the x1 by inspection of x1n. So x1 z is the z transform of x1n, whereby directly using inspection, what do you have? Okay, the A is, okay, if you look at here, what is A? A is equal to 1 over 3. Okay, you are going to use this equation over here. So you have z over z minus 1 z minus 1 over 3. Okay, so we look at this one lah. Okay, we are used to using this equation. So 1, so we write that you are using the equation, this equation, this equation. So 1 minus 1 over 3 inverse z. Okay, and don't forget, okay, I didn't put the 7 in front here. So we have x1 is what? X1 okay, is value, and then for x2 z, you have z, okay, x2 n, whereby x2 is over here, b is what? B is 1 over 2. So b is 1 over 2, and by inspection is that this equation is same as this one, right? So we are going to use the same equation of z transform. So you will write it out as 1 over 1 minus b. What is b? 1 over 2 inverse z. Okay. So now, therefore, okay, x z is equivalent to, write out again this equation, okay, just now, is 7 x1 z minus 6 x2 z. So substitute the value of x that you have, x1 z is this one, okay, x2 z is this one. So you have 7 over x1, y minus 1 over 3 z minus 6, y minus 1 over 2 inverse z. Okay, we want to find, the question is that to find the z transform, kan? So we cannot leave it like this, the equation in terms of this. So we are going to multiply. For easy calculation is that multiply both sides with z over z. Okay, so when you multiply both sides, what do you have? You have 7z minus, multiply by z, z minus 1 over 3, okay, multiply by okay, not yet multiply, okay, minus 6z z minus, okay, 1 over 2. Okay, so after this is that we need to actually expand it so that it's left in the z transform. We cannot leave it like this. This is actually what? This is actually partial fraction, right? Partial fraction. Okay, partial fraction that you actually do if you get an inverse Fourier transform. Okay, but now we are in z transform. So what you need to do is that multiply both sides. Multiply both sides just now. Okay. Okay. So you have 7z, z minus 1 over 2, minus 6z, z minus 1 over 3, okay, z minus 1 over 3, z minus 1 over 2. Okay, expand this, you get 7z squared minus 7 over 2z minus 6z squared plus 6 over 3 z. Okay, this one is z minus 1 over 3 multiplied by z minus 1 over 2. So try to settle this. Okay, so 7z minus 6z, so z squared. Then you get this one and this one. Okay, so minus 7 over 2 plus 6 over 3, right? So just cross multiply that, so minus 21 plus 12, 6. What do you get? Minus 9 over 6. So you get minus 3 over 2. Okay, so you get this one will be minus 3 over 2 z over z minus 1 over 3 z minus 1 over 2. Okay, so this is exact. Since we want to leave it in terms of the Fourier transform table, so Fourier transform table, if you look at the Fourier transform that we normally use, okay, is in this term, okay, so we want to leave it in that Fourier transform table. In this term, so if you want to leave it in this term, so you need to divide by z over z. Okay, so what do you get? You get z minus 3 over 2 y minus 1 over 3z inverse 1 1 minus 1 over 2 inverse 1. Okay, so this will be the final answer, which is find what is x, z. Okay, so we leave it in this term, in this term. So the second question is sketch the region of convergence for signal xn. So which is for exact lah. So reveal region of convergence. So B find the region of convergence. Okay, so just now you know that the signal xn is in this form. So region of convergence is that you're going to use this one, z more than a. So for the case of, you have two denominator over here, right? First one and the second one. Okay, let's say that I number it first and second. So for number one, okay, you take this one, 1 minus 1 over 3 inverse z, okay, directly by using the Z transform, okay. So you don't need to actually calculate, you directly use it. So you know that z is going to be much larger than 1 over 3. Okay, 1 over 3. And for the second one, 1 minus 1 over 2. 1 minus 1 over 2 inverse z, you have z is more than a lah. So what is a? This one is a. This one is a for this case lah. So 1 over 2. So okay, for this example is that the ROC is, you have 2. So we draw out, okay, z plane. ROC is, for example, this is 1. 1 minus 1. So for ROC, 1 over 2 is, for the first one, 1 over 3. 1 over 3 is where, if for example, if this is 1 over 2, 1 over 3 is, example is here, 1 over 3. Okay, so 1 over 3, 1 over 2. Okay, and for the first equation is that you have z more than 1 over 3. So z more than 1 over 3 is this area, okay, more than 1 over 3. Thereby you see that it's covering the unit step input lah, 1, unit step. For the second equation over here, you see that it's more than 1 over 2. Oh sorry, this one is more than 1 over 2. So another one is more than 1 over 3. More than 1 over 3 will be in this area. Okay, more than that. So in summary, when you write what is the ROC, okay, therefore, based on the xn, ROC will be more than 1 over 2. Why 1 over 2, not 1 over 3? We are going to take both shading. So you know that when we shade 1 over 3 only, this part, okay, only this part is actually shaded by both area. Only this part. Okay, this part. However, the center part here, which is 1 over 3, okay, between 1 over 3 to 1 over 2, is only covering for ROC. This one is only for ROC, Z more than 1 over 3. So it's not covering, it's only covering for between this area only. Okay, so to define the ROC for xn, for the whole system, then you need to take into account both ROC. So both ROC, which part, which it is overlapping. So overlapping is at 1 over 2. Both are overlapping because it's outward. Okay, so therefore the ROC is given by this. Okay.